Hey guys, welcome back to another Minecraft video. Today
Today, we're gonna be diving into some of the physics behind Minecraft's mechanics, and our game plan looks a little bit like this. So we all know of the infamous Chihuahua bucket, right? What we don't know is the force it takes for Steve to survive a certain foot drop. And that's what we're gonna be testing out today. So stay tuned to find out. First things first, we need to find some basic variables. And we're gonna start with gravity of Minecraft. So because Steve is falling down, we will use the equation d is equal to vt plus 1/2 at squared, and initial velocity is 0, which means we can cancel it out, and we have d is equal to 1/2 at squared. But because he's falling down, we're replacing acceleration with gravity, and we have to replace d with h because we're calculating how long it takes for him to fall a certain height. So if we do some silly stuff, we can isolate g, and we get gravity is equal to 2h over t squared. And we're gonna do that. Pan to the next epic cutscene. We're gonna be at a pillar of wood. Okay, cut. Why do I have pistons on my left hand? Okay, now we're gonna measure how long it takes for me to fall down 50 blocks. We actually already did this, and we found out that it took me 2 seconds for me to fall down 50 blocks. And it turns out that 1 Minecraft block is exactly 1 meter, meaning that I fell 50 meters in 2 seconds. And plugging that into the equation, g is equal to 2h over t squared, we get, drumroll, 25 meters per second squared. That's crazy. That's almost 2.5 times the gravity of Earth. And that is so awesome sauce. All right.
But now that we have gravity, how do we calculate the actual force? I think we're going to be using the equation J, which is impulse, which is equal to the force times change in time. And to isolate force, we get F equals J over the change in time. Therefore, impulse is also equal to the mass times change in velocity, meaning that we can relate the former equation with F equals m times change in velocity over change in time. From AP Physics 1, we remember that V equals the square root of 2gh. So our final equation looks a bit like this. F equals mass times the square root of 2gh over the change in t.
Now the thing is, we don't know what Steve's mass is. So let's take a little walk over here. Welcome to my epic class, guys. All right, to find the mass of Steve, we know that 1 Minecraft block is 16 pixels by 16 pixels by 16 pixels because it's, a cube. We also know the dimensions of Steve, and it turns out that he has 1,664 pixels. Insert a lot of math all over the screen.
Okay, so you guys are probably wondering where I got the volume from. And based on what we know, Steve's head's dimensions, his body's dimensions, and his arm and legs dimensions are shown here. And we know that 1 block in Minecraft is 16 pixels, or 1 meter. So we can use this to make an approximate ratio, where his head is 1/2 meter by 1/2 meter by 1/2 meter, and all the other dimensions are shown here. And we can find the volume, which is 1 out of 8 meters cubed for his head. His body's value is here, and 4 values of 3 out of 64 because he has 2 arms and 2 legs, which gives us 3 out of 8 meters cubed. And if we add all of these together, we will get this as his volume, 19 over 32 meters cubed. And we just have to plug that into d is equal to m over v, with this being the density of human flesh, and this we just plug in to find the mass.
And we find that his volume is 19 over 32 meters cubed. Now, the average human density is 985 kilograms per meter cube, which means that plugging that into d is equal to mass over volume, we get a mass of roughly 584.8 kilograms.
Steve needs to lose some weight.
Good one.
Remember this equation from earlier? Now that we have all the variables, we can find F. For the numerator, we have m, which is the square root of 2gh, which gives us over 29,240 over a change in time of 2 seconds, meaning that Steve has to put down 14,640 newtons of force. To put in comparison, the average person weighing 75 kilograms can exact a potential impact force of roughly 950 newtons.
To be fair though, Steve is fat, meaning that if we put that example into comparison, he would still exert a potential impact force of about 7,400 newtons. No, wait, that's not fair! You have armor! Alright Alright guys, so we're taking a little like tour around the end, and what are we going to be calculating, Master Omega Soul Cookie?
If you guys didn't know, the damage of an arrow is based on the velocity that it travels. Therefore, that means that if you can get an arrow to move fast enough, you can get it to one-shot the Ender Dragon. So, if we make the assumption that a projectile is lodged into the target after coming to a stop, and that the Ender Dragon has the same percentage of penetration of a human's fatal strike would have, we can estimate that the Ender Dragon would need to have an arrow lodged approximately 6 meters into his body. An arrow's damage formula is the base damage, 2, multiplied by the velocity of an arrow. An Ender Dragon typically has 200 health, but takes 1/4 of the damage for a body shot. And assuming this, we know that an arrow must do effectively 800 damage, yielding a velocity of 400 meters per second, which is faster than the speed of sound.
Wow, but how does that help us? What are we even trying to find? Well, using this math, we can ultimately find the material shear resistance of the Ender Dragon's flesh. The equation that was previously mentioned includes sigma, the shear strength of the material being penetrated. And here, we have a 1-to-1 replica of Mr. Greenspan. Please do not show the bald head that we did not finish building, but we have Mr. Greenspan with us, so our math must be correct. That is scientifically proven to be true.
Since we know how Minecraft's arrow recipe works, we can find the mass of an arrow. 1 oak log yields 4 oak planks. 4 oak planks, Since we know how Minecraft's arrow recipe works, we can find the mass of an arrow. 1 oak log produces 4 oak planks. 2 of these oak planks produces 4 sticks. Thus we know that 1 stick is 1/8 of a cubic meter of oak wood.
Alright. Look at how cool my entrance is. The weight of a feather and a flint piece can be found online. A chicken feather is 0.0003 kilograms, while a piece of flint is 0.01 kilogram.
Great, this recipe produces 4 arrows, like this. And so if we divide by 4, we can calculate the mass of an arrow. This ends up yielding 21.87 kilograms per arrow.
Alright.
So this is how we derive the equation. At the top of the paper here we have our variables. I wasn't entirely sure whether or not to use sine or cosine since they behave similarly, and I have no real way of gathering data, so I just assumed that it should equal f over sine theta. Also, my work here has a mistake. At the top of the page it should say pressure and not force, but I correct myself later in the work, so the end equation should be the same. The equation assumes that the final kinetic energy equals 0 and that the arrow is lodged within the Ender Dragon afterwards. And this is just the end calculation, so you can see that the material shear resistance to the Ender Dragon flesh is 412,384.67, and then the units are in kilogram meter squared per second squared.
Steve is so strong, what the sigma? Okay. No!
You go back to where you came from.
Please. Now that we have finished our physics lesson, we have to beat the Ender Dragon. But first, I set my spawn point. Woo!
No!
Just kill me, just kill me. Just kill me.